Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good morning, grade 8 learners. Welcome to our today's natural science lesson, proudly brought to you by the Gauteng Department of Education. My name is Milton Gomo. Let's look at the structure of our lesson today. The knowledge area of our lesson is planet Earth and beyond. The topic of our lesson is beyond the solar system. And the subtopic of our lesson is beyond the Milky Galaxy. Beyond the Milky Galaxy. Now, don't forget that as we go through the lesson, keep on interacting with us through our WhatsApp number 079-578-2908. As a quick start our lesson, let us go through our today's objectives. Right. By the end of the lesson, you're supposed to be able to describe what a galaxy is, and also being able to state the distances between galaxies, as well being able to describe the shape of galaxies, and finally being able to define the cluster and group galaxies. The source of our lesson is Kemp's document, page 56. Now let's look at the pre-knowledge we're supposed to recall as we get to understand our lesson. We have to recall the topics that we covered grade 6, which include the solar system, systems to explore into space, and systems to explore the moon and Mars. Not only that, also need to recall the topics that we covered grade 8, which is the Milky Galaxy. Remember, we just covered this topic recently, and it's still fresh in our minds, and with that topic, we are going to be able to understand today's topic. Right, with the pre-knowledge, we can safely answer the baseline activity, which just having 4 questions. Just get them in detail. Number 1, we're supposed to give the name of the galaxy we live in. Number 2, what shape is our galaxy? And then number 3, describe where our sun and the solar system are located in the Milky Galaxy. Number 4, about how far from the center of the galaxy is our sun located. Let's do that activity quickly in 5 minutes. Right, welcome back. Let us look at the solutions of our baseline activity. A quick recap on the questions that we have. Right, number one, we're supposed to give the name of the galaxy we live in. I'm sure you can still remember that our galaxy is named Milky Galaxy. Right, number two, what shape is our galaxy? Remember, we also once spoke about the shapes of the galaxies, but our own galaxy is spiral shaped. Is spiral shaped. Number three, describe where our sun and solar system are located in the Milky Galaxy. Right. Let's find out more about the location of our very own solar system as well as our sun. Right. We are at the edge of the galaxy on one of the spiral arms called the Orion. Okay. Orion can also be referred to as the local arm. Right. So it's called the Orion arm or the local arm. Right. Let's go to number 4. About how far from the center of the galaxy is our sun located? Okay. Our sun is located at about 25,000 light years. So the distance from the center of the galaxy to the sun is about 25,000 light years. Remember that light years are not the unit of time, but they are the unit of distance or length. Okay, so whenever I talk about the distances between the objects in space, we use light years. Remember. Right, that was our baseline activity. Let's write corrections for those who don't manage to get everything correct. But for those who really did well, keep it up as we proceed. And remember to keep on interacting. Send your solutions through our WhatsApp number 079 578 2908. Okay, as we move on, we are going to look at the terminology of our lesson that we have today. Right, the first one there is the galaxy. How do you define a galaxy or what a galaxy is? A galaxy is a collection of billions of stars, space dust, and gas. And these are all held together by gravity. Okay, so they need a force that's going to hold them together so that they can coexist. And this force is the force of gravity. Right, let's define the next one. A group. This one is the galaxy group. What is a galaxy group? It's a collection of about 50 or less galaxies. A collection of about 50 or less galaxies. And again, they have to be held together, and only one force can keep them together, and this is the force of gravity. So once we've got a galaxy, we can have more of those galaxies. We can have a number of them amounting up to 50 or less, and this becomes what is called a galaxy group. Okay, now we look at what's called a galaxy cluster. This one is a collection of over 50 or more galaxies held together by gravity. Right, just check the difference between these two groups. The first one is the galaxy group. A galaxy group is made up of not more than 50 galaxies. Right, once they are put together, they make up what is called a galaxy group. Then we've got the galaxy cluster. This one is now a group of more than 50 galaxies. Right, as you can see there in the image, we've got a group of galaxies being shown. So in that case, what we have there is a galaxy cluster. Right, we're having more than 50 galaxies that are shown in that image, and all those galaxies are held together by gravity. Then I'll come to what is called a filament. This one is a thread-like structure, right, in space, which contains galaxies and galaxy group and clusters. So now, first of all, we have a galaxy. Then from a galaxy, we have a collection of not more than 50 galaxies, and this forms a galaxy group. Then now, can even have galaxies more than 50, right? And these is now called a galaxy cluster, right? Then now we come to a position whereby we having all the galaxy clusters, galaxy groups, and all the galaxies that are held together in space, and this forms a thread-like structure which is called a filament. As we move on, we want to look at what's called a void, right? A void is just a vast empty bubble in space. This is found between filaments, right? That's a void. Then look at the universe. What then is a universe? All of existence, including all planets, stars, galaxies, the space between objects, and all matter and energy. Right. Then finally we look at what is called a mega. Right. Okay, say mega or major. Right. Now what's happening when we come with the major? This one is an action of two or more galaxies being consumed into one larger galaxy. So when you talk of a major, we're just talking about an action that takes place when we're having two or more galaxies. What do? They combine to form one large galaxy. Right, shown in the image, we're having two galaxies, right? There is the other galaxy we're talking about at the top there. That's the first galaxy. Then down there we've got another galaxy. So when those two galaxies finally combined through an action called a mega, they form one big galaxy. Right, that's all about our terminology. Now let's look at the lesson in detail beyond the Milky Galaxy. What do we need to know? Right, astronomers classify galaxies according to their shapes. Right, we need to also recall what are astronomers. Right, an astronomer is a scientist who studies stars, planets, and all the other objects found in space. So the role of an astronomer is to be able to study space, to be able to study planets, stars, etc. Okay, so when we talk of astronomers, we talk of these great scientists who are able to view through space. Okay, so now they've got a way of classifying these galaxies. These galaxies, remember, just say that we've got millions of galaxies in our universe. And these galaxies differ in size, and these galaxies differ in shapes. Now, let's look at the shapes that are mainly for these different galaxies that we have in our universe. We've got shapes which include the elliptical shape, the spiral shape, the bird spiral, the lenticular, the peculiar, or irregular shapes. Okay, let's look at the diagram that's shown there, the image. Let us look at how those shapes we're talking about look like, so that we're able to recognize that this is a spiral shape. This one is a peculiar shape. This one is an irregular shape. This one is a lenticular shape. Right, there is our bird spiral shape. There is our bird spiral shape. Now, we also have another shape. In this case, is irregular shape. There it is. That's irregular shape. We've got the spiral shape. Remember that our very own galaxy, which is the Milky Galaxy, is spiral shaped. There it is. That's the spiral shape. Then down there we've got the peculiar shape. That's the peculiar shape. This one is the elliptical shape. Elliptical shape. Then we've got the lenticular shape. So all these are the most common shapes of the galaxies that we have in the universe. So the astronomers have got a very good way of classifying the galaxies in our universe according to their shapes and according to their size. Right now, we've just been looking at our shapes. Right. And remember that our very own Milky Galaxy is spiral shaped. It's spiral shaped. Right. What else do we need to know under this? Right. Now let us look at our very own galaxy in detail before we look at other parts that we need to identify and know about in our lesson. This one is the Milky Galaxy. That's our very own Milky Galaxy, the galaxy where we are, right? We've got our own solar system, we've got our own sun, right? The Milky is only one out of a total of about 100 to 200 billion galaxies that astronomers estimate to in the universe. So you can realize how huge is our universe. It's very, very big, right? That's more than 10 times the total number of people on Earth. So you can now imagine the total number of people that we have in our planet Earth, then multiply that number by 10. The number you get is approximately the total number of galaxies in our universe. That's such a huge number. Hence, our universe is so big. Our universe is so big. We're talking about an estimate of about 100 to 200 billion, or billions here, galaxies that are estimated to be in the universe. Right, what you see on the image there is our Milky Galaxy. That's our Milky Galaxy, right? And that's the center of the Milky Galaxy. So that's a simple view of our Milky Galaxy. All right. The Milky is a spiral galaxy with the arms of stars trailing around a central constellation. So remember that the shape of our Milky Galaxy is spiral. When we look at those various shapes of galaxies in the universe, we have to identify which one is spiral shape, which one is peculiar shape, which one is an irregular shape, which one is a lenticular shape, etc. So now, our own galaxy, which is the Milky Galaxy, is spiral shaped, right? What do we need to know? It's got arms of stars trailing around a central concentration, right? Therefore, the spiral shape is due to the different speed at which the stars close to the center and those further outwards rotate. So now this shape, spiral, is produced from the rotation of the stars. Remember that the galaxy has got a lot of stars. Our very own galaxy has got more than 200 trillion stars. Okay, an estimate. So now, as these stars continue to rotate, some of the stars are closer to the center of the Milky Galaxy, while some are further away from the Milky Galaxy. So as they rotate, they sort of pull away from each other, creating this pattern, which actually ends up forming a shape, which is spiral. So the spiral shape is caused through the rotation of the stars, which differs from the location. There are some which are closer to the center of the Milky Galaxy and some which are further away from the center of the Milky Galaxy. All right. Now, with that, we can now safely do our activity 1 of the lesson. Remember, we just did the lesson activity using the pre-knowledge. Now we're going to do this activity 1 using what we've just discussed so far. Right. Give the names of the shapes of the following galaxies. This is just a simple activity. So with that, I'm just going to give you 4 minutes, then look at the corrections. Let's get busy. Right, welcome back. Let us look at the activity that we just did. Now, in this activity, we're required to name the shapes of the given galaxies in the images there. Recall those shapes. Okay, let us look at A. The first one that you see there is A. What shape of galaxy is A? The shape of galaxy A is the bird spiral shape. That's the bird spiral shape. Right, what shape is B? Now B shows another shape of a galaxy. And what shape is that? We're talking about an irregular shape. An irregular shape. Let's go to C. Right, this should be very familiar with us all because this is the shape of our very own galaxy, which is none other than the Milky galaxy. And we said our galaxy is spiral shaped. So our galaxy is spiral shaped. Then we come to shape D. What shape is that one? This is another shape of a galaxy that we have in our universe. D is a peculiar shape. That's a peculiar shape. Now go to shape E. This galaxy is shaped elliptical. That's an elliptical shape. And finally, we go to the shape F. Let's find out what shape of the galaxy is F. And this is a lenticular shape. So those are the shapes that we're supposed to be able to identify as we look at the shapes of galaxies that are found in our universe. We do the corrections and keep it up for those who did well. As we proceed, we look at the beyond the Milky galaxy. In this case, we want to find more about the galaxies, right? That's a very interesting topic because we need to find and discover all the new items or information we're supposed to know about the Milky galaxy and what is beyond the Milky galaxy. Remember, we've got many galaxies to talk about here because now talk about other galaxies which are not our own galaxy, which is the Milky galaxy, but we want to find out more that is hidden and more that we need to know about. Galaxies are massive collections of stars, dust, and gas. And remember, and these are all held by gravity. So talk of galaxies, I talk about a massive collection of billions of stars, also have dust, and good gas. And all these components are held together by gravity. Right. Now, the galaxies range in size, with the smallest galaxies consisting of about 10 million stars, and the largest galaxies hold up to about 100 trillion stars. That's a massive number. That's a very massive number. So in as much as these galaxies exist in different shapes, they also exist in different sizes, with the smallest galaxy holding about 10 million stars. And if you look at the smallest galaxies, that 10 million stars is still a huge number to talk about. So you can see how big are these galaxies, and they are very, very huge as they differ from each other. The largest one, we're talking about a galaxy which can have about 100 trillion stars. That's a very big number. All right. And if you are to note there, what is shown is our own galaxy, which is the Milky galaxy. This one is the Milky galaxy. Right. Remember that we just said in our universe we've got more than 100 trillion. We've got a lot of galaxies that are found in our universe, and now the Milky galaxy is one of those billions of galaxies which exist in the universe. And now, what we see there is a simple image of the Milky galaxy, our very own galaxy. Right. It says there are about 200 billion stars, which are found in our very own galaxy, which is the Milky Galaxy. That's a very massive number to talk about here. And remember that the sun is also a star. So when we talk about the 200 billion stars that are found in our Milky Galaxy, the sun is one of them. If you want to recall, the sun is the closest star to our planet Earth, right? Then you've got other stars which are also visible to us, but notable, the sun is the closest of them all, right? That's why it appears bigger, because it's closer to us. So in our Milky Galaxy, we're talking about 200 billion stars that are found in it, and the sun is one of them. If you want to get that image, we're having a beautiful picture that shows beautiful stars forming up that beautiful night pattern in a night sky. So that's the Milky Galaxy, as shiny as it looks, because the stars are so beautiful and shiny. Right. The universe consists of millions of galaxies. And remember that the Milky Galaxy is one of them. Our galaxy, the Milky, is one of those millions of galaxies which are found in the universe. Within each galaxy, there are many solar systems, right? Some galaxies may have only one solar system, while other galaxies may have more than one solar system, right? So, also being said about our Milky Galaxy, we've got our own solar system, and so we've got our own sun. We've got our own sun. So if you look at it, if you picture the universe, you have a picture of millions of galaxies, and now each galaxy will be having its own solar systems. For instance, our very own Milky Galaxy, we've got our own solar system, we've got our own sun, right? So all that you have to be able to understand and visualize, so that you are able to understand what is happening around your world. Okay, now our solar system, we said it is found in the Milky Galaxy. Our solar system is found in the Milky Galaxy, right? And our galaxy is called the Milky because it looks like spilled milk. Hence the name, the Milky Galaxy. This name came from the ancient Greeks who were able to study the space, and when they used to watch the space at night in the night sky, they would observe that our own galaxy looked like spilled milk, hence the name the Milky Galaxy. And if you can take a look at that image, you can easily see that it looks like spilled milk, right? So that's how the name Milky Galaxy came into existence, right? As we move on, we need to know that most of the stars of the Milky are not visible from the Earth, right? There are many stars we'll talk about in this case, but not all of them are visible. Just a few are visible from the planet Earth, right? And not we can recall that we were able to see one of the stars anytime of the day, which is the sun. The sun is a star, remember, which is found in the Milky Galaxy as one of those millions of stars. Right? The reason why you are able to see the sun is because it is closer to us than the rest of the other stars that are found in the Milky Galaxy. Hence, we can be able to see the sun. But there are some stars that you can never be able to see from planet Earth. The reason being that they are so far away from the planet Earth. Astronomers were able to determine that our galaxy is spiral shaped, right? In this case, they were able to give the shape of the Milky Galaxy. So our galaxy is spiral shaped, right? Remember, we talked about those shapes, that with the spiral shape, we've got the irregular shape, we've got the peculiar shape, we've got the lenticular shape. So all those shapes are of different galaxies that we have in our universe, and our Milky Galaxy is spiral shaped. So what you see there is the spiral shape. That's the spiral shape. Remember, we say that the spiral shape there is due to the rotation of the stars that are found within the Milky Galaxy. There are those stars which are closer to the center of the Milky Galaxy, while there are some which rotate further away from the center of the galaxy. So when this rotation takes place, what happens? These stars create a pattern and finally a shape, which is called the spiral shape. Hence, the Milky Galaxy is spiral shaped. Right. As we proceed, we want to look at what more do we need to understand about the Milky Galaxy. Right. We just say that Milky Galaxy has got its own solar system, right, and its own sun. Right. Let's find out more. The sun, and therefore our solar system, is in one of the spiral arms called the Orion or local arm. This is found towards the edge of the Milky Galaxy. So now, once we talk about the Milky Galaxy, we have to know that we've got our own solar system and our own sun. But where is our solar system located in the Milky Galaxy? Right? Our solar system is located at the edge of the Milky Galaxy. So from that image there, you can understand that this image is meant for you to understand that we can only be able to view the center of the Milky Galaxy, right, through its edge, or just at the edge of the Milky Galaxy. We don't have a clear view of the Milky Galaxy, but we just have the side view of the Milky Galaxy. Hence, what is shown there is the side of the Milky Galaxy, because we're just located at the edge of the Milky Galaxy. Right. So the sun and our solar system, these are found in one of the spiral arms. Remember, I said that our Milky Galaxy is spiral shaped, right? So which means by having different arms which are found in the Milky Galaxy. We're going to get that in detail. But within those arms, we have got this other arm, which is called the Orion arm. Orion means local arm. That's where our solar system, as well as our sun, are located. Because we're towards the edge of the galaxy, we see the Milky from the side. We've just discussed that. Right, now we come to the features of the Milky Galaxy. We said that our Milky Galaxy has different arms, which include the normal arm, we've got the Perseus arm, the Scutum, Centaurus arm, we've got the Sagittarius arm. So all these arms are referred to as the different spiral arms which are found within our Milky Galaxy. What we see there is the image of our Milky Galaxy, right? Remember, our Milky Galaxy is just one of the millions of galaxies which are found in our universe. So we want to see what is happening within our own Milky Galaxy. Our Milky Galaxy has got different spiral arms. We just mentioned them. Right, let us look at the diagram and find out the location of each spiral arm that I'll talk about here. There is the normal arm, right? This one is the center of the Milky Galaxy, right? Then we come to the next arm here, the first arm that we have there that's closest to the center of the Milky Galaxy. This one is the normal arm, right? Then we've got the crux scutum arm, okay? Then we've got the Sagittarius arm, okay? Then we've got the Orion arm, then finally Perseus arm, right? Out in the Orion arm, within the Orion arm, that's where our solar system is what? Is located, right? Remember, we cannot just talk of our solar system without mentioning our sun. So our solar system is found within the Orion arm, within the Orion arm, and Orion arm being one of those spiral arms which are found in our Milky Galaxy. Right. As we continue, now we look at the central part of the Milky Galaxy. What do we need to know? The central part of the Milky Galaxy is orange because the stars found at the center of the galaxy tend to be older than the young hot blue stars. Right. So in this case, if you are to look at that image of the Milky Galaxy, we have got those stars which are found at the center of the galaxy, right? Those stars which are found at the center of the galaxy, right, produce this orange color that we see, right? The central part then becomes orange, right? Why? Because these ones which are found at the center, the stars which are found at the center of the Milky Galaxy, right, are older, okay? Then these ones which are found at the outer part of the central part of the Milky Galaxy, these ones tend to be blue in color. As you can see, we've got two colors there. We've got the orange color, then we've got the blue color, right? Then those blue stars are young stars, okay? The blue stars are young stars. And note that the blue stars are hotter than the orange stars, right? So now talk about the young stars which are blue are hotter than the orange stars which are beyond, which are found within the center of the Milky Galaxy. So you can classify now the strength of the heat that the stars have in this case. Those which are closer to the center of the Milky Galaxy, right, they are older and less hot. And those which are outside the center of the Milky Galaxy are blue and they are water. Okay, now the spirals are bluish in color and are filled with dust, gas, and hot young stars. So all those spirals that we talked about, they are located in different parts of the Milky Galaxy. Those which are found within the central part of the Milky Galaxy carry the older stars, and those which are found in the outer part of the central Milky Galaxy, they are bluish in color, they are young and very hot. Let's come to activity number 2 as we look at what we've just discussed. Number 1, define a measure. Number 2, about how many stars are found in the Milky Galaxy. Number 3, why is our galaxy called the Milky Galaxy? Number 4, state any 3 arms of the Milky Galaxy. Then finally, number 5, suppose state any 2 shapes of galaxy. Let us quickly do this activity in 5 minutes. Let's get busy. Right, welcome back. Let's look at the activity that we just did. Activity number 2. Let's get the solutions we're supposed to come up with. First, number 1, let's check it out. Define what a measure is. Right, this one is defined as an action of 2 or more galaxies being consumed into one large galaxy. That's a measure. Right, number 2. About how many stars are found in the Milky Galaxy? We're talking about 200 billion stars that are found in our very own galaxy, which is none other than the Milky Galaxy. So we've got about 200 billion stars in our galaxy. Number 3, why is our galaxy called the Milky Galaxy? It's because it looks like spilled milk. Okay, so it looks more like spilled milk, hence the name Milky Galaxy. Right. Number 4, state and 3 arms of the Milky Galaxy. Remember, we spoke about various arms which are found within our galaxy. The spiral arms we're talking about in this case include, we can have we can talk about normal arm, got the Pisces arm, for the Scutum, Centaurus arm, the Sagittarius arm, and also not to forget the Orion arm. Orion arm, remember, is also referred to as the local arm, right? And it is in this arm that our solar system is what is located. And always recall that we talk about solar system, we also have the sun as part of its components. So all those arms are the spiral arms which are found within our Milky Galaxy. Right. So 3 arms from this list and answer using them. Right. Number 5. It says state in 2 shapes of galaxies. Right. From those many shapes discussed, okay, just pick in 2 shapes, but we're going to look at those shapes in detail. We can talk of the peculiar shape, we can talk of the spiral shape, then we've got the irregular shape, elliptical shape, lenticular shape. Other than spiral, we can have another shape, which is in this case the bird spiral. Okay, that's the bird spiral. So all those shapes are the shapes that are given to the various galaxies that we have in the universe, and from that list you're just supposed to choose any 2 shapes and then use that as a solution to the question. Right, so that is the solution of the activity that we just did. Right, notable. For those who did well, keep it up as we proceed, and for those not doing well, remember to always write down corrections. Also, keep interacting with us through our WhatsApp number 079-578-2908 as we proceed to the last part of our lesson. While we get beyond the Milky Galaxy, what do we need to know that is also very important? Most galaxies are found gathered together in gigantic galaxy neighborhoods, and these are called galaxy groups. Okay, so if we talk about galaxies, in this case, some galaxies, right? What do? They are not some, but all of them talk about here in this case. They gather together, right, and form one big galaxy family, right? And this becomes what is called a galaxy groups. Just like the name says, it is just a group formed of different galaxies, right? So it becomes what is called a galaxy group, right? So now, our Milky Galaxy forms part of a large group of about 45 galaxies, right? So each galaxy has got a way of being part of a family of many other galaxies. So is our own Milky galaxy, right? It is part of a galaxy group which has got approximately 45 galaxies, and this group is called the local group, right? That's the group that our Milky galaxy is part of, right? Just taking a close look at the groups that we have there, right? In this case, we'll talk about those galaxies being part of the local group, which means we've got other names of galaxy groups that are formed by different galaxies. So each galaxy group has got its own name. Therefore, the group that our own Milky galaxy is part of is called the local group. Right. Now, these galaxies, galaxy group, can also group up to form even larger groups, which means we've got a situation whereby the galaxies form galaxy groups, and these galaxy groups will also combine to form what's called a galaxy cluster. What are these ones? They are even larger, spanning tens of millions of light years, and can contain hundreds or even thousands of galaxies. This is called a galaxy cluster, right? So the galaxy groups combine to form galaxy clusters. Okay, so there we are. We've got a planet Earth, right, being part of the solar system, and then now solar systems will combine to form what is called an interstellar neighborhood, right? And this now combined from the Milky galaxy, which is part of a gigantic group of galaxies called the local galactic group, right? Then now, remember, the galaxy groups can now come together to form what are called superclusters, right? Then the superclusters will form what are called local clusters. Eventually, this comes to what is called a universe, right? Which is a big structure of all the galaxies that we have. Many clusters of galaxies come together to form superclusters of galaxies. Our own local group is part of the Virgo supercluster, right? Gravity holds the galaxies together in groups, clusters, and superclusters, right? Distance between galaxies are even larger than the sizes of galaxies and are measured in millions or even billions of light years. Okay? What we see there is our one Milky galaxy, but it's not alone. We've got neighbors, right, to us is our galaxy. Our closest galaxy neighbor is called the Andromeda galaxy. The Andromeda galaxy. Andromeda is 2.5 million light years away from the Milky. If one travel to Andromeda and could travel as fast as light, it will still take you 2.5 million years to go there, which means it's very difficult for you to be able even to reach that side. Okay. Now, galaxies tend to group together, and because of their very strong gravity, they latch into one another, forming bigger galaxies, sometimes as massive as 1 million light year in diameter. Their shape usually changes to look like a sphere, right? Megas can take hundreds of millions to billions of years to complete, and in the process, intense bursts of new stars and black hole formation can take place. So that's what's happening there. That's a mega wave for this galaxy and that galaxy. What's happening? They're combining, and when this combine takes place, they burst out form one large galaxy. So the action shown there is a mega, where we've got galaxy A and galaxy B, right, combining together to form one large galaxy. The Milky and Andromeda galaxies are moving towards each other, right? As you can see, astronomers estimate the two galaxies will collide in 4 billion years. We've got the Milky galaxy and Andromeda galaxies, right? Then with that, we come to the last activity. Let's just have 2 minutes for that activity. It's just a small activity because we've just discussed everything quickly. 2 minutes for that, then we'll get the solutions. Right, we'll come back as we come to our last part of the lesson, which is the activity number 3. What is a galaxy group? A galaxy group is a collection of 50 or less galaxies held together by gravity. What's the name of the galaxy group that in Milky is found? Okay, we're talking about the local group. What are clusters of galaxies and superclusters of galaxies? Right, a cluster of galaxies is a collection of 50 or more galaxies held together by gravity. Cluster of galaxies often group together to form large structures called superclusters of galaxies. Then finally, what is the size of the observable universe? We're talking about 28 billion light years in diameter. That's the activity number 3. Summary that we have for our lesson. Our Milky Galaxy is only one of billions of galaxies scattered across the universe, and given those shapes are spiral, irregular, elliptical, lenticular, and peculiar, the size of observable universe is estimated to be about 28 billion light years. Galaxies have got various shapes and sizes as shown. Homework activity you submit when you come back for the next lesson. Galaxies are composed of what? Then number 2, what types of galaxies are these? Right, our next lesson is looking at the early viewing of space. With that being said, remember to interact with us through our WhatsApp number 079 578 2908. Let's meet next time in our next lesson. Thank you.